Hello, everyone. Welcome to this session, which discusses an academic program which is suitable in times of pandemic. During a pandemic, schools are closed and then sometimes reopened and then closed again to avoid the spread of infection. And this situation is actually characterized by limited teacher intervention. So let me start by these observations that during a pandemic, the closure of schools often leads to a no face-to-face interaction between teachers and students. And this is often perceived to be disadvantageous because no classroom lectures are normally taken to hinder student learning. So a lot of schools opt for online teaching, and but then again, online learning makes it difficult to track inattentive and oftentimes unengaged students. Also, when there is no face-to-face interaction between students and teachers, one often begins to think that superior learning outcomes are not possible, especially if there is no internet connectivity, especially in many countries, um, in many parts of the world. And when there is closure of classes and students stay at home, parents are often worried because they think that they are forced to guide their children in their lessons, especially in dealing with advanced topics. So this no face-to-face interaction can be turned into an advantage. The situation can be converted into a favorable scenario if one uses a process-induced learning instead of a teacher-induced learning. So you have to have the right academic program to implement a process-induced learning, which is, of course, in contrast to the one to learning induced by a teacher. Why is that so? If you have a process-induced learning, it could transform students into independent learners, which are actually required in the era of a fourth industrial revolution, where the younger generation will have to learn uh, four four different skills in a lifetime to adapt to a changing technological scenario. And a no contact or no face-to-face interaction between teachers and students can also accommodate new results from neuroscience, and which could actually improve learning. This academic program could also bypass the lack of mature science, engineering, and math or STEM teachers, which is happening all over the world. And the program is also designed to bypass the lack of internet connectivity. And this would enable many nations with limited educational budgets to catch up with the performance of richer nations. So, what is this academic program? We'll discuss the CVIF Dynamic Learning Program. CVIF stands for the Central Visayan Institute Foundation, which is the name of our school. It's a systems approach to process-induced learning. It incorporates 21st century skills needed by the younger generation, meaning it develops critical thinking, problem solving, collaboration, and communication. And the CVIF Dynamic Learning Program, or DLP for short, has actually been applied at the elementary, high school, and tertiary levels. So what is this CVIF DLP, or Dynamic Learning Program? The CVIF DLP, especially for pandemic scenario, it has four components or four pillars, starting with the parallel learning homes, which automatically limits teacher intervention, and this is almost automatic when there is a pandemic. The second component is an activity-based learning by doing, and it involves LAS. LAS would stand for learning activity sheets The students will be doing a lot of writing, and there's no introductory lecture when they accomplish this LAS. Then they would have to have an in-house comprehensive portfolio to teach them organization. And lastly, there is an important component which is overlooked by many people, and this is strategic rest. That means nothing beyond the prescribed LAS. In normal situations, the strategic rest takes the form of absolutely no homework during their 4 or 6 years in high school. So let's start discussing about the first component, which is the parallel learning homes. The parallel learning home scheme is that you can imagine a group of students individually in their own households accomplishing and doing the learning activity sheets or LAS without any teacher intervention. And the LAS does not need any parental tutoring. Then after they accomplish the LAS, they would submit it every week to a subject teacher for evaluation and grading and so on. So what is this? What is the design of an LAS or learning activity sheet? The basic design of an LAS is that it's one concept on one page, and when you encode it in font 14, it should just fit into this one long sheet. For any topic that a teacher would like to introduce for any grade level, it could be from physics to mathematics to social sciences, one starts with a short concept digest for that particular topic that a teacher would like to introduce, followed by an example and illustration. And the LAS ends with 2 or 3 questions, and everything has to be consistent for that particular topic. And there's a series of LAS to be accomplished by the students. So the philosophy is that any complex task can be divided into, say, 10 different smaller steps. And if the teacher wishes, one small step could be further subdivided into 5 smaller steps. So this step-by-step series of learning activities build up to the required competency, a more elaborate concept. Let's take, for example, as an example, one LAS, and let's choose calculus, for example, which we normally give to our grade 11 students. So this particular activity or LAS normally would fit into a one-page long bond paper, but for this particular discussion, we have to split it into 2 pages of PowerPoint. So the activity title is a geometric interpretation of the integral, and the activity title is to interpret an integral as the limit of sum. So the students will copy this. They will know that or remind them that in previous grade levels, they learned how to calculate area of a plane, other geometric objects like squares, rectangles, triangles, and so on. And they could actually use this to solve some more complicated problems. And in this LAS, we have 3 examples. And the first example is given by a regular polygon. And to get the area of the regular polygon, you can divide this into triangles, and adding the areas of the triangles. In this case, we have 6 triangles, and everybody knows how to calculate an area of a triangle. Then adding the area of the 6 triangles, then you would get the area of this polygon. Another slightly complicated case is example 2, when you're asked to evaluate the area under the red arrow and bounded by these lines A and B. And to do that, you can divide this figure into a triangle and a rectangle. So students know how to get the area of a triangle. You add it to the area of the rectangle, and then you would have more or less an approximation of the area that you were assigned to do. Now, the third example is slightly more slightly more complicated. And this is where calculus would be necessary. You're being asked to get the area under the red curve bounded by these segments at A and B. And we can approximate the area by dividing the region, this region, into several rectangles. The height of the rectangles would be, we can start with 3 rectangles. So the height would be M1 and M2 and M3, and the width would be delta X1, delta X2, and delta X3. So you add the areas of these rectangles, and again, students know how to get the area of one rectangle. So this is the area of the first rectangle, second rectangle, third rectangle, which is simply the height times the width. Then you sum these 3 rectangles, and that's already an approximation of the area under this red curve bounded by the segments between A and B. And then we end this LAS with a question: how can we improve our approximation for the area under the curve? And of course, for those who know calculus, one can improve the approximation by increasing the number of rectangles to, say, 10, to 100, to 1000, or infinite number of rectangles, and the summation would then turn into an integral sign. So this is just an example of an LAS, and the students have to copy this for better retention, and so that they have time to absorb the lesson. So in the CVIF-DLP, an ideal learning activity is an activity where 0 teacher intervention is needed. Ideally, there should be no lecture. And in fact, for every activity, for every LAS, an introductory lecture is not allowed. We don't allow it in our school. It's not required. And the reason for this is the students will have to copy, comprehend the activity, and it develops their comprehensive abilities, critical thinking, and problem-solving abilities. So that's the second component of the CVIF-DLP, the activity-based learning activities. And one crucial component, or you can say a secret, in the success of the CVIF-DLP is writing by hand. And there are a lot of scientific studies which support this writing by hand strategy, but we'll only mention one. In a paper published in Psychological Science by Mueller and Oppenheimer, they said that note-taking with a pen rather than a laptop gives students a better grasp of the subject matter. And this study focused on more than 300 students at Princeton and the University of California at Los Angeles. Mueller and Oppenheimer demonstrated that students who write out their notes on paper actually learn more, and in each study, those who wrote out their notes by hand had a stronger conceptual understanding and were more successful in applying and integrating the material than those who took notes with their laptops. So writing by hand is naturally incorporated and is part of the non-negotiable feature of the CVIF-DLP. Also, we can cite an older study by Professor Hebb. That's why we require that writing the activities activates both the psychomotor and visual faculties of the brain. Professor Hebb said that neurons that fire together are wired together, and neurons that fire out of sync lose their link. That's generally called plasticity of the brain nowadays. And so we take advantage of that in our CVIF-DLP. And all these learning activities which they write, so this is an example of a written activity by our student, is compiled in a comprehensive portfolio. And the portfolios are color-coded, like white for math, yellow for science, blue for English, and so on and so forth. It teaches them organization at a young age, because organization is also a very good skill in the 21st century. So this is the third component of the CVIF-DLP, and the fourth is the strategic rest. That means nothing beyond the prescribed LAS. Now, this type of academic program can easily be scaled up. And in fact, in 2008, we had a project called Learning Physics as One Nation, because in the Philippines, we lack physics teachers. And to bypass the lack of physics teachers, we designed 239 student learning activities, which comprised 80% of the students' time. And this is accompanied by 18 DVDs, which are closely tied with the learning activities, because we assume that there is no physics teacher in the class. And this project was quite successful. And when it comes to performance indicators, in the Philippines, the students are given yearly a national exam, and this is called the National Scholastic Achievement Test, or recently the National Career Achievement Test. Now, our baseline data was in 2001. This was before the CVIF-DLP. So here on the y-axis, we have the number of students, and performance scores are on the x-axis. The higher scores are on the right-hand side. So before the CVIF-DLP, majority of our students were performing really, really badly. It was very heavy on the low scores, low performance end. By 2006, we had a graph, a frequency distribution of the performance of the number of students, something like this. And you would suspect that the bright students would split from the challenged learners. But luckily, by 2009, we have this type of graph, which is almost opposite to the one before the implementation of the program. And so now we have students performing quite well, but we were still worried about this tail end. And so we were happy that by 2010 and up to today, the tail end was truncated. So there were no more students performing below average. So this is one performance indicator. And of course, there are many performance indicators, and some of them would be how students are performing after they left school, after they left the CVIF. So let me just mention a few of them. We have, for example, Ronald Yoren. He's now doing marine science at ETH Zurich. And if you Google, ETH Zurich is actually #1 in marine sciences, according to the QS World Ranking for several years now. We also have one of our graduates, Madeline Naiga, who is doing her PhD at the Max Planck Institute in collaboration with the University of Dresden. And another student, Jesha Caseñas, graduated from University of California, Berkeley, with a BS Anthropology degree. And there are many other examples, but we can mention at least the three of these. So during a pandemic scenario, how do you adapt the CVIF-DLP? Well, we have a weekly distribution and collection of the learning activity sheets. And if the students have internet connectivity, then you can distribute and collect the learning activity sheets online. But then if they do not have internet connectivity, then we have drop-off stations for this at the town centers or village halls. So now that the school year has started in our school, we have 18 drop-off points. Now, once the students receive the learning activity sheets, either online or offline, they can, of course, consult each other or discuss. And this teaches them another skill needed in the 21st century, which is collaboration, and as well as communication to achieve a well-defined goal. And so peer tutoring is actually very strong in the CVIF-DLP. Even in normal times, peer tutoring is strong because it is not teacher dominated. So we receive questions such as, during a pandemic, what is the guarantee that each student is learning? Well, the guarantee is that the LAS are copied and answered in the student's own handwriting, and this involves the psychomotor, visual faculties of the brain, and when the students read it aloud, then it includes the hearing faculties of the brain. Remember the plasticity of the brain and the recent neuroscientific studies. So the mere act of accomplishing a single activity also has a certain guarantee that they are learning. Another question is that we did CVIF-DLP as distance learning. How are learning outcomes assessed aside from the tests? Remember that the LAS are returned every week to the subject teacher, and these are graded. And these LAS are compiled in the comprehensive student portfolio. So even the portfolio can be graded if the teacher wishes in terms of neatness, completeness, and so on and so forth. So the very process of doing the DLP, already you have a basis for the grades, and you can also, of course, have tests aside from the learning activity sheets. So in the pandemic scenario, what happens in the CVIF DLP? We rely on the learning activity sheets, and each LAS there is no introductory lecture that's needed. It requires zero or minimal, at least minimal teacher intervention if needed, and parents need not worry. They can relax because the LAS is designed such that no parent tutoring is necessary, and there's weekly assessment. This is in contrast to a lot of modules, and there are many modules available in the internet. But normally these modules would require teacher intervention, would require teacher discussion, which is not anymore necessary in the CVIF DLP. So our school year has started in Hagna, Bohol, where our school is located, and we tried to monitor the first 2 weeks in terms of how successful is this distribution and collection of LAS. For the junior high school, we have 1,340 students, and only 6% opted for online learning, and majority is offline. And when for the first 2 weeks, we found out that 93% of the students were able to accomplish and return the learning activity sheets. And we have the same typical numbers also in senior high school. We have a smaller number of students. 12% opted for online, 88% have no internet connectivity, but 96% were able to accomplish their activities. And we asked the teachers why some were not able to return the activities. Well, there were actually late enrollees which have not done the activities because this is just the first 2 weeks of classes. But normally, even during normal times, the LAS are submitted 100% by the students because that would be the basis of their final grade. And to summarize, the CVIF DLP addresses learner disposition, and the students actually acquire this habit, and habit is your best friend or your worst enemy, and the habit is formed through the daily protocols of these writing and learning activities. And the CVIF DLP addresses the absence of teachers. Learning activities are done independently by students 80% to 100% of the time, and this bypasses the limited face-to-face learning, especially during in times of pandemic, even with a faulty internet connectivity. Now, let's just try to answer a few questions quickly, outstanding questions during a pandemic. Can students learn well when there is shelter in place advisory to slow down the spread of infection? Our answer is yes. Can superior learning outcomes still be achieved even with no internet connectivity? Our answer is yes. Is it necessary for parents to guide their children in their lessons? How about advanced topics? No, it's not necessary for parents to tutor their children or pupils or wards. Can we bypass the worldwide lack of mature STEM teachers? Yes, indeed, we could bypass, especially if there are already prepared learning activities, even in chemistry, in physics, in mathematics. Are we taking advantage of new results from neuroscience? Yes. For example, the writing component of the CVIF-DLP. Is there a low-cost educational program that allows poorer nations to catch up with budget-intensive educational systems? And our answer is yes for this one. So when it comes to the learning activity sheets, we would like to thank the Science Core, because this PhD graduates actually helped us in, especially in the senior high school level, in designing and creating the learning activity sheets. So for example, we have Dr. Benjamin Rubin, who got his PhD in molecular biology. Currently, he's a postdoc at University of California, Berkeley. The same with Hyunjin Shim, who is now presently a postdoc at Berkeley. She taught practical research, grade 11, grade 12. And also Dr. Victor Soho, who did his postdoc at the Ludwig Maximilian Universität in Munich. He got his PhD from University College London in evolutionary biology. And our most recent one was Dr. Hyundog Shin, who got his PhD in MIT. So they created LAS, and the LAS can be found at eduversum.org/CVIF. And many LAS from grade 7 to 12 are also uploaded in this website. So thank you very much for listening.